Okay, hello everyone. Thank you for joining today's webinar. It's hosted by Vault Principal Engineer Jeff Mitchell. So as for a little introduction, Jeff is one of the first members of HashiCorp, and he started working with Vault in its infancy. Today, he'll be addressing the complexities of secrets management at scale with Vault Agent and Vault 0.11. He'll start by introducing Vault Agent, move into how Vault Agent can work with secure introduction, and demo both Vault Agent and a little bit of namespaces. We will then spend the last 15 minutes of the webinar dedicated to a live Q&A, so make sure you put your questions in the questions box. This webinar is recorded, and the recording will be made available after post-processing. That usually takes within a day or two, and you will get an email with the recording. So feel free to put questions in the meantime in the questions box, and we'll get to it during Q&A. With that, I'll let you take it away, Jeff.
Hi there, hopefully everyone can hear me. I'm gonna share my webcam. I'm not sure, someone let me know if it's showing up in front of everything else. I'm gonna talk about Vault Agent and 0.11 features. As Lynn noted, Vault Agent is something that's new in the 0.11 cycle. We introduced it in beta in 0.10.4. And what Vault Agent is. So I'm going to talk about agent first. I'm going to talk about namespaces, and also I decided to include a little bit about Aqua path templating. Okay, so Vault Agent it's a new mode of operation for the Vault binary. So just like we have the various Vault commands, and if you run Vault server, then you have a server side, the server part of Vault. Then this is a new mode of operation. So you just run Vault Agent, you give it configuration and so on. And the idea behind it, we have one piece of functionality right now that's in it, which is AutoOp. The idea behind it is that we think that there are things that, not only this AutoOp, but also things coming down the line where it will be useful to have a client-side daemon versus something that is just making single requests, getting a single response back. There we go. Okay, so AutoOp, so this automatically authenticates to Vault. And it keeps token renewed, reauthenticates as needed. And so the idea basically here is, let's say that you are standing up like an EC2 instance, or you're on GCP or something like that, or you're on Kubernetes and you want to get a Vault token. So normally you would have to say, okay, I'm going to use, let's say, the AWS auth method because I'm using EC2, or I'm going to use IAM. And I'm going to authenticate with that, and we have some like Vault kind of CLI helpers you can use. I'm going to authenticate to that, and then I'm going to get a token back, and I'll be able to use that token. But in a lot of cases, you don't want to have sort of an interactive kind of approach. You want something to, especially if you don't want to build logic to renew that token and keep re-authenticating into your applications. So if something just, if you have an init script that starts up and says, go authenticate, get a token, and drop it on disk somewhere, then you still have to be responsible for renewing that, re-authenticating as needed, and so on. And so, some people have written their own sort of daemons to manage this, and there are some things in the community. We actually at HashiCorp wrote something a while back, which was for a long time kind of a hidden part of enterprise that was available but wasn't really advertised. And so we finally were able to get that put into open source. And along with that, that was an AWS only agent, and now we have support for AliCloud, AWS, Azure, GCP, Kubernetes. And so the idea is you just put Vault Agent in your deployment, you deploy it, you add that to your init script or systemctl or something like that to run as a daemon, and it just automatically authenticates based on the environment and your config file, and provides that token to applications. And we built it, at every step of the way that we were building this, we really looked at robustness and fault failure tolerance in mind. So it tries its hardest to make sure that that token is renewed, that the token, that there's re-authentication necessary. It tries to make sure that token actually gets to the desired location, and retries everything if that doesn't work. So we really want it to be something that you just sort of like load it into your image and forget about it. So I'm going to go really quickly into the design just so you can kind of understand how it is that it works. And I'm going to show some a demo later, and so going to the design a little bit now just helps you understand like what's coming in the output. So there's an auth handler, an auth method, a sync server, and token syncs. And the auth handler does this, is kind of the thing responsible overall for authenticating to Vault. And so when it starts out, if there's no token or the token's invalid, it'll actually go to the auth method and say, okay, how do I authenticate? And the auth method, which is the thing that's key to AWS or GCP or Kubernetes or Azure or AliCloud or whatever, that returns information on how to perform the authentication. And this works very similarly to the Vault login command, which if you do Vault login and you say the type is AWS, then like it does things for you. You can look in the environment for IAM information and put that into a request that Vault can use to authenticate. So it does a lot of those same things. In many cases, uses a lot of the same logic. But it returns it instead to this daemonized process, the auth handler. And one nice thing is we can actually, and I'll demo this, is the method can actually tell the auth handler that new credentials are available. So I'll demo this using the JOT backend, but for AliCloud, this happens now. So like if it detects that there are new credentials that got rotated in, it can actually tell auth handler, hey, you should probably re-authenticate. And we're adding that support for AWS, I believe the next release. So the auth handler, once it gets this information back from the method, it uses our Go SDK's renewer primitive, which is something that exists in our SDK, to keep it renewed. And when it can't renew, it goes back and says, please, give me more information. I need to re-authenticate. And once that token is around, it passes it to the sync server. And the sync server is responsible for fanning out the token to one or more token syncs. So why would you want to do this? Why would you want to have one or more places that you write a token to? The reason is that you might want to write it into different locations, and those different locations might be something that is writable by the agent, but is readable by different processes, just so that you don't need to have kind of Uber groups configured in your systems that have all of your different application like users inside of them, just to like all be able to read the same token. So you can say, you know what, I actually just want to drop it into a bunch of different places, even though it's the same token. You can, of course, run multiple agents if you want to just actually have totally separate tokens. And that's totally doable, totally possible. But for any given sync, if it fails to write, it will reattempt the back off. So I said we tried to make sure that it was very robust. And the token sync is responsible for outputting a token somewhere. So right now, the only token sync that we have is file, which writes the token to disk. But eventually, we're thinking about things like, could we write it out over socket? Could we do a webhook-like thing where we actually have a pre-configured API request and it fills in that token information, etc. So this is, the initial release was just a little bit ago. So we're definitely like talking to customers and users for feedback about how, what other kinds of methods they would want. All right, so I'm going to give a demo, and what I did is I'll switch over to my my system in a moment, but I made a little simple test program. I'm using the JOT workflow because it's kind of easy for me to generate JOTs on the fly, and as a result, to just show that we can sort of have the method that's actually like looking at the credential information actually like poke back in and say, hey, you should re-authenticate. So it's just a useful way for me to do this. So it generates a signing key, and then it adds the JOT method to Vault, and it configures the allowed public keys. And then each time I press enter, it'll actually create and write a new JOT to the location that the agent is looking for. And on the agent side, it's configured for this JOT flow, and it will watch for a new file at the place we indicated. It'll read it, and then it actually just deletes it immediately. It'll authenticate to Vault, and then it'll keep the tokens renewed and re-authenticate as necessary. So let me switch over to that right now. Just have to figure out, all right, show. Okay. So I actually have, I'm not showing it, I actually have a fresh Vault instance running in the background, which is not configured, but I figured I would kind of go through that rigmarole right now. Okay, so this is a little demo program that's going to write a JOT. Up here, I'm running Vault agent, and actually I'll just, so this is a very simple configuration file. It's saying the method is JOT. The place where you should look for the JOT is at temp agent test JOT. The rule to use in the backend is test. And then I have one sync, and I'm writing it to a path, which is at temp token. Of course, I can't type during a live demo. Okay, so so here we have they created a file sync. We have this auth handler saying I'm authenticating. So the very first thing it did, it said, oh, there's already already a JOT that's there, and I'm going to use that. I'm going to authenticate. And you can see here, authentication was successful. It's sending it to a sink, and we wrote a token to temp vault token right there. And you can see that it's renewing right now. So over on this side, I'm just doing a quick token lookup. Hopefully it's visible. Make it a little bit bigger. So doing a quick token lookup, and we can actually see that if I run this again, that starts with 45 AD. If I run it again, 4H3E. So you can see that we actually re-authenticated. I have a fairly short TTL lifetime on these tokens on purpose, just for the purposes of this demo. So you can actually see that it is actually re-authenticating. And so after this happens, then TTL of 8 seconds. Right now it's 5 seconds, but we can see because 3 seconds got renewed, it's up to 9. And so it's taking care of that renewal for me. When that token can't be renewed, it's performing the re-authentication for me. And you'll see over here, I just have it set so every time I press enter, it'll write a new jot. You'll see that I press it, it's watching for that file. So in the up here, you'll see that every time that I press it, it's just writing a new. Well, you can't actually really see because of the way the log lines are. Okay, so every time that I do it, it's actually watching, and the auth method is saying, hey, I can actually tell the auth handler, please go re-authenticate. So, I mean, that's in a nutshell, but the whole idea is that this is something that you can build into your images. You just sort of start it up, give it a basic config file. The config file usually doesn't need any sort of like credentials in it because it uses the environment, and you just kind of like start it up, set it, forget it, and there will be kind of an always working vault token that's just sitting at the location that you specify. All right, so I'm going to close this just to get ready for the next demo. I highlighted these two things in blue, this namespaces, Aqua path templating. And the reason is that one of the things that we wanted to do for 0.11 was we wanted to really sort of ease organizational burden. And so some of those features fell into the enterprise bucket, some fell into the open source bucket. But that was a theme of the 0.11 release is how do we make it far easier to sort of organize administration and help kind of ease administration and organizational complexity within Vault. All right, so let me jump forward again. Okay, so a quick question about a quick statement about protecting tokens. There are some advanced things which I didn't really want to go into for time reasons and because I don't want to kind of get into a lot of the weeds of like kind of very advanced things in Vault. There are some ways that agent can offer some extra protection on top of just dropping a token onto disk. But in most cases, you can fairly easily do two things. One is you use file system permissions to control access, and the other is drop onto a RAM disk. So like your tempfs is often a RAM disk, and in many cases these days it's actually ephemerally encrypted. So every time you reboot, it just generates a new encryption key and uses that in memory. And that's a pretty good way to do it because that way it's live as you need it, and if you reboot, it's gone. Okay. So namespaces. So namespaces are basically like vaults within vaults within vaults. So it partitions off areas of Vault into essentially fully separate instances. Great, cool. All right. That was me trying to hide the GoToWebinar window. So partitions off areas of Vault into basically fully separate instances. And I shamelessly stole some graphics here from Chris Kent, who does Vault marketing, because I really like them. And I'm not going to go into all the specifics of the text here, but I really like the graphics here because it shows if here's your overall Vault, right? And you think of the way that Vault works where when you mount a plugin or backend, it basically creates like API paths. You kind of have like an API tree similar to a file system. And so if you have like the whole containment of your kind of API paths, well, now you can say, well, I'm going to take this section of it, and this section is actually partitioned into an engineering org namespace. And then even within that, you can partition it further and say, within the engineering org namespace, we have an application namespace. So it really gives you this way of saying, you know what, we actually have one overall Vault, but inside that, it basically feels like many different instantiations of Vault. And for the most part, it really is separate. So the underlying encryption keys are shared, because that's kind of Vault's storage mechanism that encrypts everything. So that's shared. And replication, the replication subsystem is shared, although there are provisions that we have now and working on kind of making these even nicer with namespaces to allow filtering. So if you're doing performance replication, you can filter out various mounts and working on filtering with namespaces as well. So that's that asterisk there. But per namespace, things that are entirely within a namespace are things like, what mounts you have. what policies you have, what tokens you have, the leases that you have for dynamic secrets, like database credentials, your identities. So these are all things that are per namespace. And so nearly all of Vault is basically broken up now into this way where you can have very namespace specific data. And a really nice aspect of this is that control flows down. I sort of mentioned that kind of like a file system root. And when you add a plugin, then we basically add API paths. And control flows down from the root to the leaf, similar to a file system. So parent namespaces can be given privileges in child namespaces. And this can happen, I'll demo this, but this can happen via just in your ACLs and your policies, giving direct path capability grants. So saying at this path, which actually lives in a child namespace, here are capabilities. And you can also do it with identity groups. So you can give, there's one piece of like cross identity or cross namespace functionality with respect to identity information, which is when you have a group in a namespace, you can actually allow other groups and other entities from other namespaces to get access to policies in your namespace. So that's really just designed as kind of a very specific sort of escape hatch to let it be easy for admins within a namespace to say, we actually want to give someone else coming from this other namespace, we want to give them some access, but it's in this sort of like strictly controlled fashion. And another key is that every request executes in the context of the most specific containing namespace. And again, we'll show this, but like if you have a namespace, if you have your root, then you have namespace A, and then you have namespace B under A. So you have root and then A and then A/B. If I am making a request into A/B into that namespace, then every request that I'm making at that path is operating in that namespace. So it doesn't matter what namespace my token is in, my identity is in, none of those things matter. We always scope it within the actual request. So that way we ensure that people don't accidentally escape out of the namespaces. And policies always operate at their appropriate namespaces. So policies are namespace aware, and your token policies that are granted to your token, those act at whatever namespace your token is. They can give grants down to child namespaces, as I mentioned, and as I will demo. But if you are coming into another namespace, if you're being given access via identity groups, then that's operating within the namespace of the request. So everything really is kind of sandboxed, and permission does get kind of narrowed down as you go further down the tree. You have less and less areas of permission that are available. And namespaces get special versions of special mounts. So we have these special mounts like identity and sys and cubbyhole, and we have namespace specific versions that essentially make sure that certain things happen with respect to both the paths that are available. So things like rekeying vault is not something that should happen from a namespace. So we control which paths are available, and we also make sure that certain things that happen are done within the appropriate namespace context. All right, so I'm going to demo some stuff. And it's a little bit of a long demo, but hopefully it'll all go well. Okay, so I'm going to take this. I'm going to launch a Chrome window. All right, and I'm going to open up the UI. So I'm going to do part of this in the UI and part of this in text. And the reason for that is that that way I can kind of keep my tokens separate. There's certain things that as a heavy text user of Vault, because I've been working on it for so long, I'm very used to on the text side, but also this way I'm going to sign into in with my dev root token. So that way I can keep my root token in the UI, but I can kind of flip tokens on the other side. So the first thing I'm going to do is I'm going to create some namespaces. So over at Access, namespaces, I'm going to create a namespace. I'm going to call it A. Very easy. So now I can switch this namespace. So we notice that there's a new secret tension. You can see it has NS cubbyhole, if you can see it. I don't know how much bigger I can make it without anything happening, but it has NS cubbyholes to type instead of cubbyhole because it's the namespace specific version. So I'm going to go down one so I have the sidebar readily available. So I'm going to create a new namespace. Now I'm in A. I'm going to create a new namespace. See, it says this will be saved in the A namespace. I'm going to make B. And now I can switch the namespace. And you can switch up at this dropdown over here. So I can go and say, all right, I want to go to A, and I'm at the root. And from here, I can just go back to A, back to B. So very, very simple to switch when you're in the UI. So I'm in A/B now. I'm going to create a new engine just for demo. I'm going to make a KV engine, make it version 1 just for sort of ease of the demo. And in here, I'm going to create a new secret. I'm going to call it foo. I'm going to say, the namespace, I'm just going to create a value at foo. Namespace is a/b. Technically, it's a/b/. And then I'm going to go up to root. We see that, okay, this, different amounts there. I'm going to create a KV store here that's version 1. And sorry about the dropdown. And create a new secret here. I'm also going to call it foo. I'm going to say namespace. Can't type. Namespace root. And so then we can just come over here and do vault read kv foo. We'll see namespace is root. I'm going to come here and do ns. You can also use dash namespace. So at A, I didn't create one. And at A/B, we can see the namespace value there, A/B/. So we have totally different mounts of these different namespaces. And I mentioned before that you can reach in. And currently, just to be clear, currently I'm also using my root token within the CLI. So I can reach into any namespace I want from the root token. So that's why I can kind of do whatever I want right now within with these commands across these namespaces. But you can see that I mentioned that you can reach in and always use this request context. So if I get a namespace A and I say actually I want to use a path of B/kv/foo, it all works the same, because what happens is Vault said that path that you gave me is actually a namespace A/B. So I'm going to move the request into namespace A/B, and I'm going to use kv foo as the actual request path. So that's nice. And so now I'm going to show some other really cool things about this. So to do that, I'm just going to, I'm a little bit faster on the command line than the UI, so I'm just going to do it this way. So I'm going to enable user pass. In namespace A, I'm going to create a user pass backend. User pass, users Jeff, password equals Mitchell. Very, very secure password and username there. Feel free to use it, everyone. So I wrote a user into user pass with policies badmin. I'm going to show you what badmin. Oops, I'm in the wrong directory. All right, so there's my badmin policy. So you see within the context of namespace A, which is where I created this user pass auth mount, I have a path, a policy that's going to say a path B/star, which essentially is going to reach into namespace A/B. At B star, just give me everything, everywhere. So let's write this in. NSA policy. Okay, so that's there. And we can see, like at the root, then I have NS and root. You can't do, there's no root tokens in namespaces, only at the root namespace. Oops. I did that wrong. Vault policy list NSA. So here we have badmin. So that's a policy that I wrote, which is, and you can see that the sets of policies are distinct between the root namespace and now in namespace A. They each do have a default policy, which is kind of the normal Vault thing. That just gives you things like token lookup and so on. So now I'm going to log in and actually get a token here. Method user pass, NSA, username is Jeff, password equals Mitchell. I can type my own name. Okay. So I'm logged in, and we're going to see that now that I don't have the root token, I actually can't do a secrets list in the root namespace. I can't even do it at. I can't do it at namespace A, but the policy gave me access to reach into namespace B, and I can list secrets here. So I have a token which basically can't even really do anything in my own namespace, but which I've actually delegated some permissions in a child namespace to run things. And so that's showing how you can not only do your own work in your own namespace, but actually have control flow down from the root and go down further. Okay, so that's it for this sort of quick namespace demo. I want to get to the next part of which will build on this a little bit. See if this will work. Okay. So Aqua policy path templating. So this is this is an open source, and this is that other part of what I mentioned, of kind of looking at it like how can we make things operationally much easier. And we've wanted to do this for a really long time, but we needed to get identity in and kind of plumb through all the auth backends and so on. And so this allows templating identity values into Aqua policy paths. And it's way easier to show in a demo, so I'm actually basically going to go right back into a demo because it's just much easier to do so. Right. Okay, so we're back to here. So I'm going to go. So I'm logged in. I'm logged in as root in the UI. This is the point at which I said, hey, it's actually much easier for me to just have both open. So I'm just logged in as root in the UI, and I'm logged in. And I'm going to create a KVV1 in namespace A. So now each namespace has it. So the next thing I'm going to do is I'm going to go to. So I logged in, and we can actually see. So there's an alias. So this is my Jeff alias. It came from UserPass. Let's see. So click on the entity. So this is the entity associated with it. I'm just going to, for ease of use in the demo, I'm going to make the name of the entity Jeff, and I'm going to add some metadata here, which is let's say Xmas movie Die Hard. Okay. Yeah. All right. Okay. So I just added some metadata to that, and I'm going to show a policy that I wrote, which actually might be a little easier to show on the UI, just because let me bring the text down a little bit, just to. Okay. So this policy that I wrote is showing the templating in action. So you see this path, KV entities, identity.entity.name/stars. So this is saying I want to essentially template in the name associated with the entity that's making the request here. And you can also do ID. It's more secure to use ID. For the purposes of demo, it's way easier to use name. And then I'm going to show groups. So this is saying take your identity information, look in groups, look in the names of groups that this token holder is associated with. So the groups that they are a member of directly or indirectly. And the name of the group that I want to use is admins. And then use the group name. And the same thing, you can do IDs. You can also do groups by ID. You can do a lookup, so it's pretty flexible. And that reminds me, I actually need to create a group real quick called admins. I'm going to add a policy filtered A. Group. Sorry, I forgot to do one thing real quick, which is I need to copy this to add it to my group. Okay, create a group. Admins, add a policy filtered A, add my entity ID. Okay, so I now have that group that we can use, and then I'm going to show some metadata here. So I put an Xmas movie there, and I'll show you what that looks like later. Okay, so I'm going to take this policy, I'm going to add it to the UI because I'm logged in as root there, so it's very easy to do it. Create an Aqua policy named filtered A. Pop it in. Okay, so I'm going to token lookup. So tokens in 0.11 in enterprise has come to open source in 0.11.2. We've actually flipped. We sort of changed the format of tokens. When you are using tokens, you should consider them opaque values. And we have always been kind of consistent about that so that we can do things like this. So we actually put a namespace identifier on tokens now. And except for the root doesn't have it. And so that's so you can do things like a vault token lookup without having to actually specify the namespace. And that's just a much easier thing to do, where then you don't have to be like, oh crap, I forget what namespace I logged in last. I'm logged in with some like token. It'll show you the namespace path, and you can just do a token lookup regardless of what namespace you're making that request to. So it's just a little bit easier. And you can see now, because I was added to the group, filtered A is coming in as one of my identity policies, and I select admin from my token. So now I'm just going to show some writing. So vault write, and this is all going to be in the context of NSA, which is where my token is. So let's say I misspelled my name as Jerf, and permission is denied because it doesn't match a policy. So I fix that, and I can write. And that comes down to here, this identity.entity.name. It's taking that from my entity. It's saying, what's the current name? And the reason that you should use ID when possible is current name is the key part of it. Names can be reused. So what's the current name? They can't be reused at the same time, but if an entity is deleted or changes its name, it could get reused. So it's safer to always use the ID. And I can do, vault right and say KV groups. And let's say that I do group admin instead of admins. So that doesn't work because that's not part of the policy. But if I use admins, I am a member of a group whose name is admins. And so this actually basically does, it does kind of a membership check and then says if you're a member of it, doesn't match this name. So that's nice. And then let's say there's an age-old debate about just to show some metadata. There's an age-old debate about your favorite, what's the best Christmas movie of all time? And my wife would say Elf, but she's wrong, which is why that doesn't work. But if I say Die Hard, then of course it does work because it's taking that out of entity identity right here. It's looking in metadata and taking the value of the Xmas movie key. So that kind of templating lets you do all sorts of really nice things. So you can also reach into things like identity aliases. So let's say that you have people logging in from LDAP, and you know that the LDAP UID is never going to change. So you can say, I actually want to create essentially a space within KV where people can, kind of like what cubbyhole does for a token. You can basically say, I want to allow anyone that logs in, I want to allow them to use an alias from my LDAP account. And I want them to use that alias name, which is never going to change, and be able to just write whatever they want into this specified KV path. And that KV path will be different. Only that entity will actually have access to it. Anyone else that logs in and is mapped to a different LDAP user won't have access there. So it's almost like cubbyhole, but for entities or for identity, which is super cool. And we don't even need a special backend for this. It just is a very simple kind of path block in your policy. So there are really nice things you can do, and especially combining things like namespaces and this together, it just makes for much nicer organizational workflows at larger scales. So that's it for me. I'm going to stop showing. I guess we'll move on to QA.
Awesome. So I think one of the first questions was, can you elaborate on what cubbyholes are and how they work and their use cases?
Sure. Cubbyhole is something that's been in Vault for so long that it's easy to forget that if you're new to Vault, like you may actually not have an understanding of what it is. Cubbyhole is per token storage. So every token that exists can write to its own cubbyhole, unless you. So that is part of its of like the default policy, and there's a reason for this, both because it can be useful just if you want to just stash something real quick, but in a secure location and read it back later. So it works basically like a very simple KV store, but it's token scoped. Now token scoped, not entity or identity scoped. So if you log in twice, get two different tokens, you have two different cubbyholes. But one really important property of this is that there's something in Vault called response wrapping, which I'm not going to go into here. If you go to the Vault documentation site, you look up concepts and response wrapping, then we have kind of a detailed explanation of it. But it basically allows you to transport things across relatively insecure channels and not necessarily prevent the wrong people from getting information, but be able to detect if the wrong people got that information, which in many cases is about the best you can do. And that basically is something that is a first-class capability within Vault that's used for a lot of things, and that you yourself can there's a wrap TTL flag. So if I'm, let's say I want to do it. I'm not sharing my screen anymore. There's a wrap TTL flag that you can use with almost any value, like on the CLI, or almost any command that you can make, which will have a response token, a response wrapping token get returned to you. And there's a Vault unwrap command that can unwrap it. But essentially, it combines cubbyhole, this per token storage, with single use count tokens. So this is a one-time thing. So when we have a response wrapping token, when you unwrap it, that token is gone. And so that's sort of a way in which, based on the fact that data only is hidden behind this tokenized value and goes away, you can essentially pass that token somewhere, and if that that token is not able to be unwrapped, then you can actually kind of raise that as an immediate security alert. But you can do that if there are places where like you have to pass in envars in insecure ways, let's say. Then instead of passing a secret in the envar, you can pass in a response wrapping token and then unwrap it inside your container or unwrap it inside your process and have a pretty good idea, especially if that's happening very rapidly. And if you can unwrap it, that nothing else saw the contents of that data. So that's sort of a long explanation, but that's what cubbyhole is, and that's one of the big uses of it is response wrapping. But because the way that it works, it has to be available to every token. So you see it if you do like a secret list, you'll see it in all namespaces, and it's always there in Vault because it's a first-class managed backend.
Cool. The next question is, does agent become aware of the TTL configured on the Vault role as well?
Agent becomes aware of the TTL that's configured on the token. So when the token is returned, it has a TTL, and it uses the TTL that's given to decide when to first attempt renewal, and then if that fails to keep attempting renewal up until it hits a certain like threshold, at which point it says, you know what, this is not renewing, or I've detected that even when I try to renew, the TTL doesn't go further anymore because we're hitting the max TTL. The max upper limit, in which case I'm going to re-authenticate. So that data is returned by Vault, and when a TTL comes back on a lease or a token, unless it's administratively revoked, it's a contract. So agent can know as long as nothing else has administratively revoked that token, that TTL is something that it can calculate a threshold and it can use. So it's not directly aware of the role, but it is aware of the role then dictates the TTL on the token, and then the agent sees the TTL on the token.
Cool. The next question is, you mentioned that credentials aren't really necessary because auth agent just uses the environment. Can you expand on that?
Yeah, so in many, that's not always true, but in many cases, so like a lot of people that are using AWS, for instance, use IAM credentials, and so those are the IAM credentials that Amazon, if you assign it like an instance profile, Amazon will assign credentials with appropriate permissions. It'll rotate those credentials for you. You read those credentials from like the metadata endpoint, and so essentially the agent says, oh, you're running with AWS, you're using like type IAM, and it actually will use on AWS, it will use the normal kind of AWS credential chain, which allows either static configuration of secrets, environment, a credentials file, or IAM provided ones through the metadata interface. So in most cases, people will actually just say, here, I want my EC2 instance or my Lambda function or whatever to have enough permissions for Vault to be able to authenticate it, and just assign that and have AWS automatically generate those credentials. And so in that case, Vault agent doesn't need those credentials. You don't have to configure anything. It just says, I'm going to go try to get it from metadata, and as long as it can do that, get it from the metadata service, you're fine. And so most of the cloud plugins operate that way. So that's why I'm saying in most cases, you don't have to pre-configure credentials.
Well, the next question is, would the agent be able to see if a Vault password was rotated?
So agent isn't, so Vault password, I'm going to assume that it means like if I change a value in KV. That's not something it does now. It's something we are considering, sort of like what console can do, like console watch. It's something we're considering. One of the reasons that we've put it off for a long time, besides the fact that we just had so many things we want to do in Vault, and there are many other things we want to do in Vault, is that there are people using Vault at a very, 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 very high scale, and we're concerned about things like so console, when you're doing like an agent, each console agent that's local to your host has like an RPC connection to console. Console is designed for many, many, many of those RPC connections to be handled at once. But Vault isn't necessarily, in many cases, people deploy Vault in ways that don't necessarily have a high open file descriptor limit, which can be changed. But we're essentially kind of concerned about people running tons and tons and tons of agents and making sure that Vault can properly handle all those connections without any problems. Just because ongoing sustained connections, when you're running like a software as a service, like at cloud scale, this is something that they do, and this is often farmed to many, 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 many servers. If you have a single Vault server and you have, suddenly you have 100,000 like constant connections that are just sitting connected to Vault, we just want to make sure that we're ready for that. Is more or less the answer. So we are looking into that. It's something that we want to do at some point. So Vault Agent would then be kind of the obvious way for that to be implemented, but we don't have that right now. If they meant when like a password for a credential that's being used to authenticate for AutoOp, when that's rotated, it depends on the method. So Ollie Cloud right now, if the method will look for rotated essentially, I forget the name, Ollie Cloud's version of IAM. It'll look for rotations of those credentials and then automatically say, please go get a new token now that I have new credentials. And we're working on that for AWS. So I sort of answered both questions there because I wasn't sure in which way it was meant, but hopefully that's useful.
Great, thanks. The next question is, could you describe an example use case for Vault Agent where it reduces the complexity of using Vault?
Yeah, so we've actually had many customers over many years basically say, I wish I didn't have to write my own shell script just to get a Vault token. And basically what they say, like, okay, I know that I can use the Vault CLI, but right now I have to basically create my own shell script to do all of the authentication, which isn't hard. And then embed that into, let's say, my EC2 instance. It's not hard to do that. We have kind of we have guides, we have docs, but where that gets challenging is now let's say that you want to renew that token. So it's not that hard to get an initial token in one of these environments. We save you work now, like you don't have to hit the metadata endpoint, do some curl slicing, JQ slicing and dicing, send it off to curl, do whatever. We're saving you from having to deal with that with just kind of a simple configuration file. But the real key is renewal and reauthentication. So if you want to create a simple bash script that then sort of daemonizes and sits there and like watches for new credentials or like tries to figure out when the token needs to be reauthenticated, needs to be renewed, that's significantly harder. Now your bash script has become much more complicated. And now you're probably looking at writing your own program in Python or writing your own program in Ruby or Go or whatever, just to do that. And the problem is that a lot of companies have done exactly that internally. And there are also some, there are many like kind of open source projects that people have stood up on GitHub that basically does that for some method or another. And so what we had wanted for a long time and what we sort of finally got out the door is just a centralized way to do that. Like we have the code to do this authentication because we have the CLI helpers. And we knew how we wanted to build this, and we knew that eventually we would want a Vault agent. We just needed to actually kind of get there. So I think that, for the very simple case of getting that initial token, it's not necessarily less complex. Once you add reauthentication into the mix, and once you add renewal into the mix, it's saving you a lot of effort.
Awesome. Next question is, would the agent be able, will there be a way to do auth against a custom auth plugin using the agent?
That's a really good question. So the short answer is I don't know. We just haven't gotten there yet. We have a way. I think the answer might be like if you are running your own. Let's see. So like right now, if you're running your own plugin, if you're using open source Vault, you're building your own version of Vault. You can build in your own like CLI helper. I think probably the answer is going to be relatively the same, which is you can always build your own version of Vault Agent. So you could write your own auth method just using the interface that's there, which hopefully won't change, although it's very, very new. So I can't promise that it won't if there's a real reason to do so. But this agent is fully open source. So you could essentially take, and by the way, this is a really important point, is that our API, our CLI, even if you're an enterprise customer, there's absolutely no difference between the CLI code and the API code and the agent code between open source and enterprise. And so if you are building your own custom CLI to send out to your users, and you are building your own Vault agent auth handler, or auth method, I should say, then you're getting no functional difference except for the addition of the functionality that you added. So if you have your own Vault plugin, that's probably an easy way to do it. I don't know if there's going to be an easy way otherwise to sort of like have some kind of like plugin interface. It probably would be as difficult for you to write both to that plugin interface and then, and for us to implement that and have that work well, to just build Vault yourself, to be perfectly honest. So my guess is that it should be too hard, but probably that would just be something where if you're doing your own custom plugin development, then just distribute your own custom CLI and just add your own auth method.
Cool. There have been several questions actually on the potential integrations between Vault and Console. So some of these include, just general integration between Vault agent and Console template. And then the others include, since both Vault and Console can act as a CA for SSH, how would you kind of reconcile both Vault and Console at once?
I'm not aware of Console being able to act as a CA for SSH. Did I misunderstand the question?
No, that was the question. I guess another question along these lines is, how does Vault Agent token renew work in tandem with Console template that can also renew tokens?
Sure. So that story isn't baked yet, and part of it is that on the Vault side, we haven't had time to go and actually do that. We were very, very busy with namespaces and Aqua templating and everything else in addition to agent. So we just haven't really had time to get to that yet. And also, currently, at least the Console team owns Console template, and I don't know the current state of that roadmap right now off the top of my head. That said, I think probably off the cuff, Console template can ingress Vault tokens and then use them to write stuff out. I don't know if we'll ever embed kind of like what Nomad does. I don't know if we're ever going to embed Console template as a library into Vault agent, because that will sort of balloon the complexity of agent itself. And I think that we'd rather try to keep those separated. We're HashiCorp, we like the separation of principles and the Unix model and all that kind of stuff. So probably we'd keep those separate, but my guess is that right now Console template, if it has Vault token, it will try to keep it renewed, and it might simply be kind of a flag or something that says, hey, if hey, this token is actually coming from Vault agent, or just turn off renewal, essentially, like turn off renewal and watch this file, or like, hey, here's the Vault agent token file that you can read it from. Or if we like build a socket method, maybe it just like opens up a listening socket and that automatically turns off renewal and lets the agent handle that, and it just listens for new tokens coming down the wire. So that's my guess. I just don't have a firm answer right now. It's too new.
Cool. Okay, next question is, can agent cache secrets from Vault in a secure manner?
By the way, one other quick thing I thought of is you can run Console template in like a once mode. So one thing you could potentially do then is actually have Vault agent manage your token, and then run Console template with -once on essentially a cron job or something, like on a fixed time. So that your database tokens or database credentials that it's generating or that you're writing secrets every hour. So just invoke Console template every 30 minutes in a cron job, and that might be kind of a very upfront way of dealing with that until there's sort of a better integration story there. And now that I thought about that and circle back to that, I forgot the new question. Sorry, can you please repeat it?
No worries. The question was, can agent cache secrets from Vault in a secure manner?
So cache secrets from Vault. No, it doesn't. It does not cache secrets from Vault. It's something we've thought of. I'm not saying it will never happen. What I will say is we don't have a good story for it right now. And part of it is that it's difficult to. So just walking through it a little bit. Let's say that you want to then be able to make your requests to Vault agent, and I know that CyberArk has something like this. I think that I have heard, I haven't used CyberArk. I have heard that Vault generally runs faster than CyberArk, and so a lot of people find that caching to be less necessary. But one thing that we haven't really figured out a good solution for, we don't really like building things in unless we feel pretty good about them, is the authentication. So if Vault Agent is available on a host, and it is it is just running on, say, a local host IP socket, and you connect in and you make your Vault request there instead of to Vault directly, then the question becomes like, how do you authenticate that request? Can anything that gets on the box just make a local host IP connection and just get whatever it wants? One way might be to cache values per token. So if we know that a token has been written out, and we know that the token's lifetime, if we're responsible for renewing it, then we can say, all right, at the end of whenever this token expires, and we're actually going to just dump all of these out of memory. And you have to actually know the token in order to get it. Maybe that's a way to do it. We just haven't. We don't have that yet, and I'm not. I think right now we just haven't really heard that's necessary. We have some ideas around this, which I hope to be able to announce for HashiConf. We'll see if that happens, about kind of further upping Vault scaling. Right now, we don't generally hear of reads as the problem. It's writes that we hear of as the thing that's boggling Vault down, especially around authentication. So many authentications a second, causing a lot of writes in Vault, and that sort of bogging things down. So that's something we're very focused on. But we don't really just hear about read operations being something that is expensive and is problematic for our customers.
Cool. We have time for just one more question. This question is, you mentioned there being a theme of reducing operational burden in Vault 0.11. Do you see any features on the roadmap that may help automate configuration? For example, configuring secrets engines, policies, etc.
I hit the wrong button. Yes, but I can't talk about it yet.
Awesome.
That's all. Sorry. I don't know what the time frame is, but it is something we've been looking at, and that's all I can say right now.
Great. On that note, we just have 4 minutes left, so I'm going to close out. So thank you everyone who submitted questions, and to Jeff for fielding all the answers. I hope everyone has a better understanding of the upcoming of the Vault Agent feature. If you want more webinars, you can go to our website at hashicorp.com/events. We will be announcing some product updates at HashiConf. So if you haven't explored HashiConf, feel free to see if you can attend. It's in San Francisco in October. Finally, as I mentioned, this webinar was recorded. We'll make the recording, slides, and answers available after post-processing. We'll send an email out to everyone who registered with the recording link, and you can also keep an eye out on social. And that's it. So have a great day, everyone, and thank you for attending.
Yeah, thank you, everyone.